All right. So I define oxidation as loss of electron is defined as oxidation. Leo, the lion, said girl. Guys, there are some other ways that you can look at a chemical reaction and see if something is oxidized or not. Very simple method. It's not different method, it's simple method, simpler method. If you see something, an element or a compound on the left is adding oxygen, is gaining oxygen, reaction is called oxidation. But this is an oxidation. So potassium is oxidized. K is oxidized. Why? Sorry. Why? Because it doesn't have oxygen before, it has oxygen now. So addition of oxygen is defined as oxidation. In this reaction, do you see carbon doesn't have oxygen? When it is converted to CO2, we say carbon is oxidized. So addition of oxygen to anything is defined as oxidation. Look, SO2 is becoming SO3, is added oxygen, so SO2 is oxidized. Addition of oxygen is defined as oxidation. And you can prove it, it's really loss of electron, but it's easier way of looking at the appearance on oxygen, appearance of the equation, and you say the starting material, SO2, C, and K are adding oxygen. The product has more oxygen than before. Then we say that reaction is oxidation. Is there another way to look at the equation and say it's oxidation or not? Loss of hydrogen is also called oxidation. Loss of hydrogen is oxidation. Therefore, gain of hydrogen is reduction. So loss of hydrogen is defined as oxidation, which is the same as Leo. You can prove it's really loss of electron by easier method. Just look at number of hydrogen. Number of hydrogens before how many? 4 hydrogens. Number of hydrogens after 2 hydrogens. This has loss of hydrogen, so we say CH3OH is oxidized. Loss of hydrogen is oxidation. And of course, if I show you a reaction which takes H2CO and converts it to CH3OH, you're starting with 2 hydrogens, and you're ending for hydrogens. Can I say this is gain of hydrogen? So this is a reduction reaction. It is reverse of oxidation. Why? Hydrogens are added from 2 to 4. Addition of hydrogen is reduction. Loss of hydrogen is oxidation. And if I go to next slide, again, definition, oxidation is loss of electrons. Loss of electrons or oxidation. Leo. And whatever is oxidized is defined as reducing agent. If I gain money from you, I have lost I mean, I have caused loss of money by you. So whatever is oxidized, which is losing electron, causes gain of electron by another agent, because it's a transaction, and gain of electrons was reduction. So whatever is oxidized is called reducing agent.
If it's reduced, is it called an oxidation agent?
Yes. In other words, if let's say electrons are money, or money is electron, dollar is 1 electron. If I get $1 from you, I have caused reduction of your money. So I'm a reducing agent, and I gained electron, so I'm oxidized. In other words, what happens in transaction between two people, between two things, between two reagents, they're always opposite. I gain electron, I am -1, I'm reduced. You lost electron, you're +1. I gain $1, my transaction is +1. The dollar came from you, your transaction is opposite to +1, which is -1. When something is oxidized, causes reduction to the other reagent, because it's a transaction. I can't gain money from you and you gain money. That's not possible, right? I gain money from you because you lose money in a transaction. So gain and loss are opposite to each other. So when you see ing, it means what is this reagent doing to the partner? If it is oxidized, it causes reduction. If it is losing electron, it causes gain of electron by the other partner. Any questions? Okay. So did we say reduction is gain of electron? Gain of electron is reduction. Whatever is being reduced, it causes oxidation to the opposite partner. So things which are reduced are called oxidizing agents. Things which gain electron are reduced. But where is the electron coming? From another reagent. So they cause loss of electron to their partner. That means loss of electron, remember, loss of electron was oxidation. Whatever is reduced is oxidizing agent. Whatever is oxidized is reducing agent. Because there are always two partners involved. If you and I are exchanging money, you can't exchange money without me. And I can't gain or lose money without you. If I gain, you lose. If you gain, I lose. That's it. There are two components in a transaction. If I go to the next slide, this is called oxidation number rule. By using this rule, you can also decide what is reduced and what is oxidized in a reduction oxidation reaction. So we have to make some definitions to be able to decide in a transaction in a chemical equation what is oxidized and what is reduced. Rule number one, guys, as we have said, as you already know, all elements have a charge of 0 because they have equal number of electrons and protons. So can I say, I'm going to define charge. Let's say oxidation number is really charge. If I say zinc plus 2, the oxidation number of zinc is plus 2. If I say zinc metal, this doesn't have a charge. So oxidation number is 0. So oxidation number in a way is charge on the metals.